scientists have made a bold declaration. They have discovered a celestial body distinct from any other previously known. NASA, renowned for its groundbreaking revelations, has revealed that this planet is captivating not only because of its size and location, but also due to its emission of light that seems to be synthetic. Could we be on the verge of unveiling concealed realities that might profoundly transform our understanding of the universe? Could this finding suggest the potential existence of life on other planets? By examining NASA's pioneering discoveries, we may soon uncover the facts behind this remarkable occurrence. In 2007, NASA initiated the Dawn mission with the objective of investigating some of the most intriguing entities within our solar system. Equipped with 3 ion propulsion systems, Dawn embarked on its journey. Commencing with a 14-month investigation of Vesta, the second-largest asteroid in the belt, Dawn transmitted exceptionally detailed images and data, illuminating Vesta's intricate surface features and diverse geological past. Upon completing its mission at Vesta, Dawn advanced to the subsequent phase of its voyage, one that was likely even more exhilarating: a thorough examination of the dwarf planet Ceres, thanks to its ion propulsion systems. Dawn was able to break free from Vesta's orbit and head toward Ceres, a feat that would have been unattainable with traditional chemical propulsion. These propulsion systems provided consistent thrust, enabling Dawn to traverse vast distances and establish a stable orbit around Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi. Ceres is the largest object in the asteroid belt, situated between Mars and Jupiter. For 4 years, it was classified as a planet, until its reclassification in 2006 as the smallest dwarf planet in our solar system. With an approximate diameter of 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt, one of the most captivating due to its unique characteristics. Scientists eagerly anticipated the first close-up images of this mysterious planet, which revealed brilliant spots scattered across its surface, especially in a large crater known as a crater. These luminous spots ignited immediate curiosity and speculation within the scientific community. Before the Dawn mission, the best images of Ceres were blurry, low-resolution photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be composed of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the potential for cryovolcanism, a volcanic eruption that releases water or brine instead of molten rock. But what exactly are these enigmatic lights? And what do they reveal about the true nature of Ceres? Are they signs of ongoing geological processes, or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, its mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015. This was a significant turning point, as it prepared to offer the first detailed perspectives of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial photographs showed a cratered surface, suggesting a history of impacts. However, what drew the most attention were the mysterious, bright spots in the planet's gloomy, rugged terrain. As the image's resolution improved, scientists began to formulate theories about the nature of these spots. Were they areas of ice reflecting sunlight? Or could they be something even more remarkable? Speculation ranged from mineral deposits to possible signs of chilly activity. To everyone's surprise, a closer look revealed that the brightest spot wasn't just one feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits, remaining after water sublimated. This suggested that Ceres Hador possibly still has some form of geological activity capable of pushing water or brine to the surface, where it rapidly evaporates, leaving behind bright, reflective residues. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our understanding of the possibility of life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a combination of hydrated minerals and water ice, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition suggests that Ceres may contain substantial amounts of water beneath its surface. Its outer layer is rocky but porous, with trapped ice and other volatiles making it resemble a comet more than a typical asteroid. It is thought that Ceres has a unique internal structure consisting of a core that contains a lot of water ice, which accounts for roughly half of the planet's total volume. Ceres' mantle is probably a brine and rock mixture surrounding a denser core, possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres may have once supported liquid water, especially if its core was heated by radioactive decay in the beginning. Composition distinguishes Ceres from its neighboring asteroids. The composition of Ceres distinguishes it from its neighboring asteroids and opens up fascinating questions regarding the possibility of geological activity and the role of water in shaping its development. But that's not all. The identification of ammonia clays on Ceres suggests that this dwarf planet might have originated in the colder, outermost regions of the solar system before migrating inward. The presence of ammonia could lower water's freezing point, allowing the presence of corrosive liquids on or near the surface. These insights into Ceres' structure and past not only expand our understanding of this captivating dwarf world, but also offer crucial clues about the processes that drive the formation and transformation of icy celestial bodies throughout the solar system. Cryovolcanism and volcanism is a fascinating and relatively uncommon geological phenomenon, especially when contrasted with the more familiar volcanic activity on Earth. Rather than spewing molten lava, cryovolcanoes or ice volcanoes eject substances such as water, ammonia, or methane. These substances can persist in liquid or gaseous form in extremely frigid environments. On Ceres, cryovolcanic activity allows salty water to ascend to the surface. Once this briny mixture encounters the vacuum of space, it swiftly undergoes sublimation, transforming directly from solid or liquid into gas. What remains are reflective salt residues that appear as the mysterious bright spots seen on the planet. One of the brightest of these is located specifically in the Achater crater region, nicknamed Spot 5. This site has drawn considerable attention due to its extreme reflectivity and observed temporal variations. These shifts are believed to be linked to water sublimating, suggesting that cryovolcanism may still be active or occurred recently. In addition to Spot 5, Ceres contains numerous other luminous spots, each exhibiting unique traits. These are not limited to a single region, but are dispersed across the planet's surface, indicating that the phenomenon may be widespread. The vitality of Ceres is emphasized by their existence and contradicts earlier assumptions that, as dawn broke, it was a still, dormant body. As the Dawn mission continued transmitting increasingly detailed images, it revealed a surface peppered with craters, each narrating a chapter of the planet's story. Insights from scientists and their theories about this new world have fundamentally changed how we perceive Ceres, with its icy makeup and signs of potential cryovolcanic processes. The planet now stands as a dynamic and evolving entity, no longer merely a frozen relic. Bright spots and scientific interest. The brilliant spots, particularly those in crater, continue to pique the interest of scientists. They may represent not only geological activity, but also processes that suggest Ceres' ability to retain subsurface water. Studying Ceres provides broader implications than just learning about a single dwarf planet. By analyzing its internal layout, surface, bright deposits, and anomalies, scientists can derive insights into the behavior and evolution of other icy bodies within our solar system. The substances found on Ceres, such as water, ice, ammonia-rich clays, and salts that reflect light, can shed light on the chemical compositions and environmental dynamics of similar planetary objects. Moreover, this opens the door to thrilling new directions in understanding geological activity, not only on dwarf planets and icy moons in our solar system, but also on faraway exoplanets. This indicates that regions once believed to be inert and uninhabitable might, in fact, support complex natural processes. Could this also indicate that distant planets once dismissed as frozen and barren might hold the conditions necessary for life? Final thoughts on the Dawn mission and humanity's cosmic pursuit. NASA's Dawn initiative continues to be a shining example of the potential of cosmic exploration. The information it delivered has already changed science's perspectives on the birth and transformation of our solar neighborhood. As we delve further into Ceres' enigmatic mystery and others like its each piece of evidence helps us assemble the larger story about how planets, moons, and other celestial formations evolve. Currently, the luminous regions on Ceres stand among the most fascinating puzzles of planetary science. But they represent only the beginning. As advancements in technology continue and newer missions are deployed, the chances for even more groundbreaking discoveries increase. Ceres, once an overlooked speck in the asteroid belt, now emerges as a symbol of promise and intrigue. Its multi-layered terrain, interior, and cryptic shining spots might one day unlock keys to understanding the mechanisms and youth of the solar system that forged its planets. The potential for microbial life, or at least the elements necessary for life to exist on Ceres, remains a thrilling concept that keeps researchers and space aficionados motivated alike. As our journey of exploring distant frontiers progresses, the boundaries between imagination and reality blur ever more. What was once confined to science fiction, the possibility of alien life has become a genuine scientific question. Could microscopic organisms thrive in Ceres' hidden reservoirs? Might the conditions found on other icy celestial bodies prove hospitable to life forms that we are either familiar with, if yet to imagine? These are the mysteries that will inspire the next era of space research and, perhaps, one day, reveal the deeper truths of the universe.